Number 7, the Amaterasu Particle. In May 2021, detectors scattered across the Utah desert caught something arriving from the direction of the cosmic void. The telescope array picked up a cosmic ray particle carrying roughly 40 million times more energy than anything the Large Hadron Collider has ever produced. Researchers named it Amaterasu after the Japanese sun goddess. What's mysterious about it is that when tracing the particle's path backward, it pointed straight into the local void, a region of space that is practically empty of galaxies, black holes, and theoretically anything capable of producing a particle with that kind of force. Empty space doesn't accelerate things to those speeds, so what is powerful enough to fling a single particle across the universe where our telescopes picked up, which supposedly was an impossibility? Newer analysis in 2026 suggests the trail might actually lead to a nearby star-forming galaxy hiding just outside that void, while a separate Penn State study proposes the particle could be an ultra-heavy atomic nucleus rather than a simple proton, one dense enough to survive the journey across intergalactic space without losing its energy. 60 years after the first cosmic ray mystery showed up, we're still chasing the machines capable of building and producing these monsters. Number 6, phosphine in Venus's clouds. Venus is the last place anyone expected to find any possibility of life. With surface temperatures hot enough to melt lead in clouds made of sulfuric acid, and yet in September 2020, a team led by astronomer Jane Greaves announced they had detected phosphine gas drifting in Venus's upper clouds, a molecule that comes almost exclusively from industrial pollution or living microbes. Within weeks, other research teams reanalyzed the same raw data and came back with completely different conclusions. What followed was years of challenge and counter-challenges. What's very unusual is that even scientists who doubted the original detection agreed that nobody has identified an ordinary lifeless chemical process that can produce phosphine in Venus's harshly oxidizing atmosphere. That leaves two possibilities. Either an entirely unknown branch of atmospheric chemistry is happening that nobody on Earth has ever observed or predicted, or something alive drifting through the clouds of Venus is producing it, where the temperature and pressure happen to resemble a day on Earth. Space agencies aren't waiting around for an answer. Missions like Verve and Envision are being designed specifically to fly through those clouds and settle the question. Because there might be a chance that life is possible even in the harshest of conditions. Number 5, the WTF Star. In 2015, NASA's Kepler Space Telescope flagged a distant star doing something nobody could explain. It was dimming by up to 22% of its brightness for days at a time, with no rhythm nor patterns at all. Astronomers initially nicknamed it the WTF Star, which stood for Where's the Flux? And flux is the technical term for any dip in a star's brightness, normally caused by a planet crossing in front of it or some predictable internal change, but nothing here was predictable. The pattern was such an anomaly that one astronomer floated the idea that maybe this irregular dimming is what you'd expect from a massive structure built by an advanced civilization to harvest energy directly from the star. NASA's Spitzer and Swift telescopes eventually traced most of the behavior to an uneven cloud of dust drifting around the star. But dust alone doesn't explain everything, because the star has also been fading steadily for over a century by roughly 14% between 1890 and 1989. We just have no idea why nor what's causing it. And until somebody does, the strangest star Kepler ever found keeps the door open to the possibility of extraterrestrial life. Number 4, Saturn's Hexagon storm. You're probably seen infrared satellite images of a hurricane or a storm, but at Saturn's North Pole sits a storm shaped like a hexagon and wide enough to swallow 2 Earths with room left over. Storms on Earth are chaotic blobs that dissolve within a week. This one has held its exact geometry since Voyager spacecraft photographed it in the early 1980s, and it was likely spinning long before that. So why does it have corners? NASA's Cassini spent 13 years and 294 orbits around Saturn and still couldn't fully explain it. The leading theory by Harvard researchers suggests that smaller storms hugging a circular jet stream squeeze it from the outside, pinching a circle into 6 flat sides and pushing upward to form the hexagon shape. But the problem is that it's nearly impossible to test and confirm it, because Saturn takes 30 years to orbit the Sun, which means its North Pole is in darkness for roughly half that time. We have the photographs and a working model. What we don't have is a conclusive explanation with evidence, but it's something we'll likely have the answer to in the next 30 years. Number 3, the Hubble tension. Imagine measuring your own height with 2 different tape measures, both independently proven accurate, and getting 2 different numbers every time. That's the Hubble tension, cosmology's most stubborn argument. Measure the universe's expansion rate using nearby stars and galaxies, you get roughly 73 kilometers per second per megaparsec. Measure the same number using the cosmic microwave background, the Big Bang's afterglow, you get roughly 67. Those numbers are supposed to describe the same constant in the same universe. NASA paired the aging Hubble Space Telescope with the newer James Webb Space Telescope specifically to triple-check the local measurement, hoping to expose a hidden calibration error. Instead, Webb confirmed Hubble had been right the whole time, the worst possible outcome if you wanted a simple explanation. And newer data from the Dark Energy Spectroscopic Instrument has only widened the gap. Astrophysicist Adam Reyes has said that with measurement error essentially ruled out, what's left is the thrilling possibility that we've misunderstood the cosmos itself. Maybe dark energy isn't constant. Maybe there's a force or particle nobody's found yet. Solving this would mean understanding and rewriting the age, size, and ultimate fate of everything in the universe. Number 2, the Great Attractor and the Dark Flow. Our entire galaxy is moving, and not in the direction simple cosmic expansion would predict. In the 1970s and 80s, astronomers noticed nearby galaxies all drifting in the same direction, like water swirling toward a drain nobody could see. They called the unseen source the Great Attractor, and for years it stayed hidden directly behind our own galaxy's star fields, in a stretch of sky nicknamed the Zone of Avoidance. Technological advancements in telescopes eventually punched through and found a likely culprit, a dense cluster of galaxies called Norma, sitting roughly 220 million light-years away. Case closed, except it wasn't. A separate team at NASA's Goddard Space Flight Center studying how galaxy clusters scatter the cosmic microwave background found something larger and stranger underneath. They called it dark flow, a uniform drift among galaxy clusters across billions of light years in a direction nothing visible can account for. So whatever is pulling on that scale, all data points that it would have to sit entirely outside the observable universe. If that's true, it means there's structure to reality we will never be able to see directly, only infer from how everything else leans toward it. Number 1, the sun's coronal heating problem. The closer you get to a fire, the hotter it feels. That's just simple thermodynamics. But imagine being further from the source, and instead of feeling cooler, it actually feels significantly hotter. It breaks all logic. And that's exactly what is happening on the sun. Scientists call this the coronal heating problem. The visible surface of the sun is about 5,500 degrees Celsius. Its outer atmosphere, the corona, runs over 1,000,000 degrees, sometimes even reaching up to 3 million. That is roughly 200 times hotter even though you are further from the core. It's like walking away from a campfire and suddenly catching fire. For decades, 2 rival theories have fought for the explanation. One camp argued for nanoflares, where billions of tiny magnetic explosions are detonating across the sun's surface every second, each releasing roughly the energy of a 10 megaton bomb. The other blames Alfvén waves. These are electromagnetic ripples propagating upward through the solar atmosphere and depositing their energy once they hit the corona. NASA built the Parker Solar Probe specifically to fly into the corona and settle the argument. In 2024, it ruled out magnetic field kinks called switchbacks as the primary heat source. It didn't provide any conclusive data nor get us any closer to solving it, so we are still trapped in theory. Solving this would mean predicting coronal mass ejections, the solar explosions capable of disabling power grids and satellites worldwide with a precision that currently does not exist. The sun is 93 million miles away, and we still do not understand how it heats its own atmosphere. Thanks for watching. Like and subscribe to see more.